Hello, welcome to Study Guide Forum. Today we'll be looking at the possible question that we were likely to see in a 2023 Waec exam, the chemistry practical, the volumetric analysis. We have a question here. The question says that A is a solution containing 0.1 mole of hydrochloric acid per dmq of solution, and B is prepared by dissolving 1.25 grams of sodium triazo anhydrated in 250 cm cube of solution. Now, the other thing that omitted here is the process of the titration, adding it in the burette, as it is in the burette, titrating against 25 or 20 cm cube of the B. So from the result, say that from your result and information given, say calculate the concentration of B in mole per dm cube, volume of N, this N in triazo carbonate hydrated. So they said that the last one here, percentage water of crystallization. So we have equation of the reaction there for us. So at the end of the titration, we were able to have these values. Now look at the arrangement. The volume of the pipette used, indicator used, which is methyl orange. And looking at here, this is what we have. The rough titer, we have 14.3. First titer, we have 14.1, 14.2 in the second, and 14.1. So in this case, we are going to use this. We're going to take the average of the A used, average of A, we can use this one that are closely related. Their readings tends to be the same, and we can omit this, and we don't normally use the rough titration. So that means two of these joined together, and when we divide it, in fact everything will give us the same 14.110 cm cube. That is our average titer. So in this case, the next thing we're going to do now, we're going to calculate the volume, the concentration of B in mole per dm cube. To do this thing, what we're going to do here is we're going to use our relation of this equal to A over B. And our A is what? From the chemical equation, the ratio of A is what? 2, and B is what? 1. And concentration of A is 0.1, equal to 0.1. And what again do we need? The volume of B, which is 25 cm cube. 25 cm cube, and then we're going to find the concentration of B. Now concentration of B is what we don't know. So what we're going to do here is we use our values, the concentration of A times volume of A divided by concentration of B times volume of B, which is 25, equal to 2 over 1. Then when we cross multiply, if we cross multiply this, so what we're going to have here will be, so if we cross multiply, we'll have a we'll have 0.14 all over times 25. So crossing over, we'll have this will give a 1.41 equal to this multiplied that will have 50 over CB. CB will then be 1.41 over 50. That will give us 0.028 mole. 8 mole per dm cube. So this is what we have, 0.028 mole per dm cube. So the next thing we are going to do now is to calculate the value of the N in the equation in the formula. We leave this in here. So we'll come over to this page to calculate this value. The value of n in the compound. Let's just say yes. This is in the compound. So what we have here will be mass conc of hydrated salts over molar mass of hydrated salt equal to mass of anhydrous salts and molar mass of anhydrate salt. Let me just do it like that. So what we have here, the mass of hydrated salt. From here we know that the hydrated salt is this. The hydrated salt is this one we have here. So what it means is that 250 cm³ of the hydrated salt contain 1.25 grams. Therefore 1000 will contain 1.25 over 250 times 1000 over 1. That will give us 5 grams. 5 grams of the hydrated salt. That's the concentration. So the next one we'll do here, we're going to get the mass of anhydrous salt. The mass of anhydrous salt we can find that one by, that we have mole is equal to mass over molar mass. That's the molar mass of the anhydrous salt. That means this one is equal to 106. And the mass of this is what we are looking for. We don't have it. We can call it okay, let's leave it at mass. The mole of this is what we have here, which is we can say 0.02828 equal to mass over what? Molar mass. So to get this very molar mass means that since sodium is 22 times 2 plus carbon, which is 12, and then plus 3 bracket 16. So everything when we multiply it and add up those things, you have a 106. So let's go ahead. Mass of this. Mass, if you cross multiply, you find out that the mass will be equal to this 0.028 times molar mass, which is this. That will give us, so what we have here will be, our molar mass will then be, so the mass of anhydrous salt will then be equal to this multiplying, we will have it to be 2.97 grams. 2.97 grams, that's what we have. So this is mass for this. Molar mass of anhydrous salt is the same thing as this 106. So what we're going to do now is to substitute based on what we have here in order to get the mass in question. So what we do is that mass conc of this is 5 of the hydrated salt. The mass conc of the hydrated salt is 5. Molar mass of hydrated salt is this plus N18, because we don't know the value of N, and we know that water itself will give us what? 2 hydrogen plus M16 will give us 18. So equal to the mass of anhydrous salt, which is all over molar mass, which is 0.106. So what we do again is we'll go ahead. I believe we are together in this, so just pay attention as I go ahead and try to get the whole thing done. So the next one we'll do here, we can cross multiply. If we cross multiply 5, we multiply that 5 times we have bracket plus n18. So this multiply, what we have there should be 3 and 530. That will give us bracket 18. So to open this bracket, we divide both sides by 2.97. That will give us something that will look like this: 106 plus 18 equal to 530 divided by 97. That will be equal to, that will give us 178.5. So when we move this one over to here, by subtraction, we'll have 18 is equal to 178.5 minus 106. So what we have will be 18 equal to this subtracting. We have 72.5. 72.5. So 72.5 will give us, what we have now will be n will then be 72.5 divided by 18. That will give us n will be equal to 4. That means this one is equal to 4. So the next one we're going to do is we're going to calculate the mass of the percentage of water of crystallization. So to get the percentage of water of crystallization, we're going to keep something aside here. We know that the mass of the hydrated salt is 9 point this, and the mass of the mass of anhydrous salt, this is anhydrous, this one is 5, is what? Gram for what? Hydrated salts. This is the gram for the hydrated salt. And for us to get the mass of water here, means that when you subtract this from that, when you get this anhydrous from these 5 grams, we will get our mass of water. So what we do here is, that means mass of water will then be equal to 5 minus 2. That will give us, that will be grams. So now mass of water of crystallization will then be mass of water over what? Mass of hydrated salt, which is 5, times 100 over 1. That is to get the percentage water of crystallization. Percentage water of what? Crystallization. Water of crystallization. So what we have here should be 4.6%. So this is what we have. Thank you so much for being here, and we will encourage you to subscribe if you have not, and then so that you always enjoy our classes if you subscribe. And I want you to share, let your friend know about this, and then I wish you the best.